All right. So here comes some fun and interesting and exciting and long problems, but it's okay. It says a manufacturer of bicycles builds racing, touring, and mountain models. The bicycles are made of both steel and aluminum. Before I go on, I'm going to look and see if it tells me what my variables are, because sometimes it does, and this one does. Let X1 be racing bikes, X2 be touring bikes, and X3 be mountain bikes. So we're going to have to set up our own linear programming problem. So here's my hint to you on that. I usually make a table to do that, and I always want my variables going across the top of my table because they're going to turn into equations. So this was racing bikes, this was touring, and this was mountain bikes. All right. And it says the bicycles are made of both steel and aluminum. So this is all my little scratch work going on here. Steel and aluminum. It says the company has available 98,800 units of steel. That means once we add up the steel from all of these bikes, it needs to be less than or equal to the 98,800 units that it has available. And it has 32,400 units of aluminum. So once we add up all the aluminum, it's going to be less than or equal to 32,400 units of aluminum. All right. It says the racing, touring, and mountain models need, and so this is respectively, 19, 26, and 38 units of steel. So 19, 26, and 38 units of steel. And they need 9, 15, and 12 units of aluminum. Complete parts A through D. How many of each type of bicycle should be made in order to maximize the profit if the company makes, and so they're about to give me some profit stuff, $8 per racing bike, $12 per touring bike, and $22 for each mountain bike. Okay. So this is my scratch work. I'm now going to set up my linear programming problem. I want to maximize my profit, which they usually call it Z. I call it P, they call it Z. But my profit, which is this bottom row here, it's going to be 8x1 plus 12x2 plus 22x3. All right. And that's actually part A. You type that into part A of the problem. That's the objective function. But we're going to do this subject to, and now I'm going to write out my inequalities. When I write them out, I'm going to do 19x1 plus 26x2 plus 38x3. I'm going to leave a little space right here between my equal sign, and then I'm going to put equals the 98,800. I'm going to have to change that. Okay. And that was my steel. So I'm actually going to write steel. And then the next one, I have 9x1 plus 15x2 plus 12x3. I'm going to leave a little space and say, oh, I don't want to say equals yet. Less than or equal to, my bad. Less than or equal to 32,400. And this is my aluminum. And then technically you're supposed to say it doesn't make sense to have a negative number of bikes. So X1, X2, and X3 all have to be greater than or equal to 0. I'm erasing my scratch work here. So what we've just done is we set up our linear programming problem. Okay. What it's going to ask for on this problem is it wants you to type in the objective function, and then it immediately asks you for the answer. Okay, but there's no shortcuts. This is how you're going to have to do it. All right, so to solve this, first thing I'm going to do is I see the 3 at the bottom, x1, x2, x3, and say great, but I don't use those for simplex method. Then I'm going to rewrite my inequalities using slack variables. So for this first one, 19x1 plus 26x2 plus 38x3 is currently less than or equal to 98,000. There's something I could add to it to make it equal 98,800. And what I'm going to do over here, since I already have x1 is racing bikes, x2 is touring bikes, and x3 is mountain bikes, I now have S1, and it's on my steel equation. It is going to be leftover steel. On my second inequality, 9x1 plus 15x2 plus 12x3 plus a slack variable, we'll say S2, equals 32,400. And S2 is going to be leftover aluminum. Once you rewrite those using slack variables, you then want to move everything in your objective function over to the left side. So I'm going to subtract these all to the left, and I'll have negative 8x1 minus 12x2 minus 22x3 plus z equals 0. So now I can set up my initial tableau. My initial tableau, I'm going to write out my variables. I have an x1, x2, x3, 2 slack variables because we had 2 inequalities, my z augmented with my constant, my objective function, the boss, always goes on the very, very bottom below the bottom horizontal line. So just the coefficients here. And then my other 2 equations, I'll put the coefficients in the middle. Oh, that's not cool. Okay, so let me kind of point out to you, I mean, we still have a ways to go on this problem, but let me point out to you issues I've seen in the past of why you will want to show me your whiteboard with your work on it. Is something like this, I would see students, instead of doing 98,800, somehow that turns into just 98,000. Okay, we all make little mistakes like that. So if it just randomly turns into 98,000, then all your numbers in the end are going to be wrong, right? But if I'm looking at your whiteboard and I see that's all you did was you accidentally turned the 8 into a 0 in the middle of the problem, then you'll get back a whole bunch of points. Okay, so showing your work is important. All right, so we have our initial tableau. Are we finished? No, we have negatives in the very bottom row. So we pick the most negative number, which is that one. So that's our pivot column. Both of the numbers above it are positive. So I'm going to divide them over here. So I have 98,800 divided by 38 gives me 2,600. And 32,400 divided by 12 gives me 2,700. I want to go with a smaller quotient. And so this is my pivot element. Okay. As soon as you are ready to pivot, then you're going to want to go straight to that tab. And this is going to be a 1, 2, 3 rows. Got to touch my keyboard. 3 rows by 1, 2, 3, 4, 5, 6, 7 columns, and then click New Tableau. All right. Stop me if you have questions. I'm going to type this in, all my numbers. Let me know if you have questions. Hello. All right, let me double check that I typed them in all right. Okay. So once you get them all typed in, you're ready to pivot. So we are going to click Go Pivoting. Boom. And then we have to tell it which one we want to pivot on. And we do that by just clicking on it. So we want to pivot on this 38 right here. So I'm going to click it. And it pivots. And so then we look and we ask ourselves, self, are we finished? And we answer ourselves, yes, yes, we are. There are no negatives in the bottom row. That's great. We only had to pivot once that time. I'll never give you a problem that you have to pivot more than 3 times, but usually it's once or twice is what it is. All right, so I'm going to write down my new tableau. So I have X, oops, I need to make this smaller. I have X1, X2, X3, S1, S2, and Z. And then I have 1/2, 3, 3, 13 over 19, 129 over 9. I'm not even making these pretty. They're ugly columns, so I'm going to cross them out anyway. My computer's about to black out. Hold on a second. Because it stopped writing. Okay, are y'all there?
Yeah.
Okay, I don't know why it's been doing that, but I'm just thankful it always comes back on. All right, so 1, 0, 0. And then our S1 is like 1 over 38. Ugly stuff, ugly stuff. And S2 is 0, 1, 0, and then 0, 0, 1, and then 2,600, 1,200, 57,200. No. 100. No. No. Yeah. Yeah. All right. So I wrote down my new tableau. Okay. So now I want to read off my answers. So I'm going to cross off my ugly columns. And so X1 is ugly, so X1 is 0. X2 is ugly, so X2 is 0. X3 is pretty. S1 is ugly, so S1 is 0. S2 is pretty, Z is pretty. All right. Then I'm going to read across row 1. And I have 1x3 equals 2,600. Then I'm going to read across row 2, and I have 1s2 equals 1,200. And then I'm going to read across row 3, and I have1z equals 57,200. So interpreting my answers, because it's going to then ask, what is the maximum profit and how many bikes do you need to sell and stuff like that. So just, pay attention to what it's asking. But basically my maximum profit, now I'm going to write it right here. Maximum profit is going to be $57,200. And that occurs when, so there were 0, and I got to go back up here. X1 was racing bikes, and X2 was touring bikes. So when 0 racing bikes, 0 touring bikes, and then X3 was 2,600. So, and 2,600 mountain bikes are produced and sold. Okay. And then I have to see if there's any leftover material. So S1 was 0. S1 represented steel. So there's no leftover steel because S1 was 0. But S2 was 1,200. So there are 1,200 units of aluminum left over. Yay! And that was a fun-filled linear programming problem from start to finish. I know you enjoyed it. I know you're thinking, wow, I hope she does 2 more. You're in luck. I am. All righty. Are you going swimming? All right. Oh, so then the last question, because it's an A, B, C, D on this particular problem. I hate the part D's. In fact, when you're taking a test and you get part D's like this, I'm just going to give it to you. But just so you know, because it says what would help make a higher profit or something like that. Just so you know, the correct answer is always on this problem. The correct answer is always going to be that the company, oops, didn't mean to do that. Why is it not working? All right. The company might need to lower the price of one type of bicycle in order to like